Okay, so let's look at 11.7. So in a cylindrical coordinate system, a point P in space is represented by r theta z, where the r theta is the polar representation of the projection of P in the xy plane. So I've drawn a picture here of a point in 3 space. So the coordinates of the point in cylindrical coordinates would be r theta z. So if I project this point down onto the xy plane, you'd have an r here, and theta would be the angle between the x-axis and our r vector. Okay, let me draw a picture of this right triangle, say right here below it. Okay, so I've drawn this right triangle down here. So this side is y, this side is x, so I've labeled them here. Now let's make some observations using some trig functions. Let's look at first, say, the cosine of the angle. So the cosine is adjacent over hypotenuse. Let me write that here. So cosine is adjacent over hypotenuse. And the adjacent side here is x and the hypotenuse is r. So it's going to be x over r here. So we get x over r. So that we can solve this for x, then let's multiply both sides by r. So let's do that to solve for x. So doing that, we get an x equals r cosine theta. Now let's look at the sine of theta. So the sine by definition is opposite over hypotenuse. Let me write that here. So opposite over hypotenuse, and the opposite would be y here in my triangle here. So it'd be y over r. So let me write here. So y over r. I could then solve this for y by multiplying both sides by r. So multiplying both sides by r, then we're going to get y equals r sine. So let me write it here. Okay, so we get y equals r sine theta. And the last thing to notice here is this is a right triangle. So using Pythagorean theorem, x squared plus y squared is going to equal r squared. So let me write that here. Okay, so we have r squared equals x squared plus y squared by Pythagorean theorem. Now, let's look at an example now. So I'm going to erase this stuff now. So let's look at an example. Okay, so our first example says convert cylindrical point to rectangular coordinates. So we're given a point in cylindrical coordinates. So it'll be r theta z as 2 for the r, 3 pi over 4 for the theta, and 1 for the z. So we need to convert it to x, y, z notation. So let's use the things we just derived. So let me write them down. So we're going to use x equals r cosine theta, y equals r sine theta, where the 2 is a r, and the theta is 3 pi over 4. So let's plug into these then. So plugging in, we get this. The first one will be 2 cosine 3 pi over 4, because again, 3 pi over 4 is the angle, 2 is the r. And here I'll have 2 sine 3 pi over 4. Okay, so you could use your calculator on these, or just make sure you're in radian mode, but this should be an angle that you know. So 3 pi over 4 is in the second quadrant, and the reference angle would be pi over 4. So in the second quadrant, the cosine is negative. So it'll be negative cosine of pi over 4, which is square root 2 over 2. So it's going to be then 2 times negative square root of 2 over 2. And in the second quadrant, the sine is positive. Reference angle is pi over 4. So this will be, so the sine of pi over 4 is square root of 2 over 2. Okay, so this 2's cancelled there. We got negative square root of 2 here. 2's cancelled here. We got square root of 2 here. Okay, so we found the x and y now. Now we can convert the point to rectangular. So let me do that. Okay, so hence in rectangular coordinates then, so rectangular would be x, y, z notation. So we'll have our x first, which is negative square root of 2. Then our y, which is square root of 2. And then our z. But up here, our z value is 1, so it'd be 1 here. Okay, so we're done with this example. Let's look at another example now. So I'm going to erase this now and do a second example. Okay, so next example, convert point from rectangular coordinates to cylindrical coordinates. So we're given a point in rectangular, so we're given it in the form x, y, z. So the x is -1, the y is -3, and the z is 5. Let's first find the r value. So recall r squared is equal to x squared plus y squared. Okay, so we need to write the point in the r, theta, z form. That's cylindrical coordinates. So we'll first find the r. So the r is going to be square root of x squared plus y squared, and our x in our case is -1. So it's going to be -1 squared plus -3 squared square root, which is square root of 10. So that's our r value. Now let's try and find the angle. We already have the z, which is 5. We just need the angle now. So let's use our cosine and sine, guys. So let's do that. Okay, so then sine would be y over r is how we derive from the first picture when I derived the cylindrical at the beginning. So sine is y over r. So the y is -3, the r is square root of 10. And let's also do the same thing with cosine. So then the cosine would be x over r, so it would be the -1 over square root of 10. So both the sine is negative and the cosine is negative. So we have to figure out which quadrant the angle must be in. So we have the sine being negative and cosine being negative. So I claim that forces the angle to be in the third quadrant. So let me draw a unit circle to show you how I got this. Okay, so recalling, I'm going to call S sine theta, C cosine theta. So here it says unit circle. So the points in a unit circle you can think of as cosine sine. So pretty much the y part is the sine, the x part is the cosine. So in the first quadrant the sine and cosine are positive. Second quadrant the sine's positive, cosine's negative. Third quadrant the sine's negative and the cosine's negative. In the fourth quadrant, the sine's negative and cosine's positive. So over here we have that sine's negative and cosine's negative. That means this theta angle must be in third quadrant. Okay, so let me write that here. So hence we can say theta is in quadrant 3. So recall how these trig functions are defined. So we have to use a inverse trig function. So recall how these inverse trig functions are defined. The inverse cosine gives you an angle in the first or second quadrant. That's how it's defined. The inverse sine gives you an answer in the first or fourth quadrant. That's how it's defined. So you can see neither one gives you an answer in the third quadrant. So we're going to have to adjust a bit here. So let's do inverse cosine on both sides. So I did inverse cosine on both sides, but that's not going to give me the theta angle. I'm going to call it theta 1 instead. I'll explain why in a second. Okay, so call it theta 1, the inverse cosine of -1 over square root of 10. So plug this in your calculator. My answer is going to be in degrees, so put your your calculator in degrees to get this answer. So it looks like it's 108.43. Let me write it here. So it's 108.43, but again, that's giving me the answer in the second quadrant, so I'm going to have to adjust it to put it in the third quadrant now. So let me draw a picture. Okay, so I've drawn a picture here. So there's my theta 1 to 108.43, and this is the reference angle over here. So the angle that we're looking for is the angle in the third quadrant that has that same reference angle. So pretty much our theta that we're looking for will be 180 plus the reference angle, because 180 would put you to here, and then add the reference angle will put you to here. So that'd be my theta that I'm looking for. So let's find the reference angle. So the reference angle, let me write it here. So the reference angle is going to be 180 subtract theta 1. Theta 1 is 108.43. So it'd be 180 minus 108.43, which is 71.57 degrees. Okay, let's figure out our theta then right here. So theta would be just 180 plus 71.57. Let me write it right here. So my theta then would be 180 plus 71.57, which is 251.57. Now I can write my point now in cylindrical coordinates. So we have the r, theta, and z now, so let me write it up here. So our value was square root of 10. Our angle we just found was 251.57 degrees. And our z value is just right here, which is 5. Okay, so we're done. That's the point in cylindrical coordinates. Okay, so I'm going to leave it there in this video. I'll pick it up with spherical coordinates in the next video.